In this problem, we're looking at the future value or the ending balance of a $700 investment that pays 12% interest compounded monthly, and it's given by this function here. So we start off with $700, and it only grows 1% every month, and T is the number of months after the investment is made. So that's what compounded monthly means. It means it's 12% in a year, but they basically pay you 1% a month. The question is, at what rate is the investment growing after 3 years? That's going to require a derivative. So A prime is going to be the natural log of 1.01 times 700 times 1.01 to the t power. So to figure out how fast it's growing after 3 years, we'll do A prime of 3. And A prime of 3 is going to be the natural log of 1.01 times 700 times 1.01 raised to the third power. And that gives me about 7.18. Really important, again, to look at what these units represent. So A is the ending balance, and the balance is measured in dollars. T is the months after investment made. So that means our units for this would be dollars per month. So that means that in 3 months after investing, balance is growing at a rate of $7.18 per month. So in the next month, after the third month, we would expect the balance to increase by about $7.18. In letter B, we want to use logarithms to find the inverse function that gives the time as the output based on the time that it takes to make a desired amount. So in this case, we need to divide both sides by 700. We get equal to 1.01 t. Now I'm going to convert to logarithms, so I read this as t is the power. T is the exponent on the base 1.01 to get a over 100. In letter C, I want to actually find the derivative of this function. So to find t prime, we recall that we need to find the derivative of the u, which in this case is 1/100th times a. So t prime would be 1/100th, that's the u prime. So there's u prime, times 1 over the natural log of the base, which is 1.01, times 1 over u, which in this case is a over 100. If we were to simplify down here, we would get the 100s to cancel out to make this a little bit easier to work with. And we'd get 1 over the natural log of 1.01 times a. Now we can go ahead and evaluate t prime of 1200. T prime of 1200 would be 1 divided by the natural log of 1.01 times the a, which is 1200, and I get about 0.08. So now the question is, what does this represent? What is this measuring? Well, with A and T, where A is in dollars and T is in months, A prime of T would give us dollars per month. Well, T prime of A, which is the inverse, the inputs and outputs are switched, would give us months per dollar. Okay, so that means that, well, let's see, A is 1200. So to get $1,200 on the original balance of 700, excuse me, not to get, I should say, when the balance is, I should say it even better, when the balance is 1200, To make an additional dollar, it will take about 0.08 months. So this is still illustrative of how quickly our money is growing, except in this context it's telling us, well, how many months would have to pass to make an extra dollar? And we would hope that as our balance grows larger and larger and larger, it would take less time to make each additional dollar. Kind of a tricky way of thinking about it, but it's still a valid method.